The morning starts at home, far from any industrial laboratory. There is a common misconception that chemistry only happens inside specialized facilities, but the logic of matter defines your entire routine from the moment you wake up. It begins at the bathroom sink. Soap is engineered for a specific chemical task. One end of the molecule attaches to oil, while the other grabs onto water, allowing you to rinse dirt away. When you brush your teeth, you are protecting your enamel, the hardest material in your body, from the wear and tear of daily use. In the kitchen, the burner's blue flame provides energy to heat the water inside this kettle, currently in a liquid state. Absorbing that heat triggers a physical change. It gains enough energy to escape the kettle and enter the air as vapor. When you pour that water through a filter, you are performing a separation. The hot water extracts the oils, the caffeine, and the aroma from the coffee grounds, leaving the spent solids behind. No new materials were created. You simply moved the compounds you wanted from one place to another. This entire morning routine relies on the constant management of materials. You are living inside these chemical processes without having to think about them. By midday, the kitchen functions as a laboratory. Cooking is the process of tracking where energy goes and how materials are rearranged. Every ingredient on this scale represents a specific physical mass. Softening a pot of beans in a pressure cooker requires a continuous payment of energy from the stove to change the structure of that mass. When you drop garlic into hot oil, the heat triggers a transformation of matter. A new aroma fills the room, signaling that the original ingredients have changed into a new material. This logic applies to your afternoon chores as well. Detergent uses the same mechanism as soap to fight grease on a shirt collar, and a motorcycle engine burns gasoline to convert stored energy into movement. Even a neighbor's blood pressure medication is a precise chemical substance. It was designed to interact with the body's systems in a specific, measured dose. Every action you take, from washing dishes to using a mobile phone battery, is a series of energy payments and material transfers. These same principles that manage your kitchen also drive the economy of Rio Grande do Norte. The state's largest industries are built on the same laws of physics and chemistry you see in your sink. In the salt flats of Macau and Mossoró, the industry performs a massive separation process. The sun and wind drive the evaporation of seawater, leaving the dissolved salt to crystallize on the ground. While oil drilling has historically been the economic anchor for the region, the coastline is now dominated by these wind turbines. They harvest kinetic energy directly from the constant coastal winds. Further inland, massive solar farms like this one capture energy from the sun. These projects create thousands of jobs for people to install, clean, and monitor the technology. This abundant wind and sun is now supporting the start of a new industrial sector, green hydrogen. This process uses renewable electricity to split water into its component gases. When standard fuels burn, they release carbon dioxide, but burning hydrogen returns it to the atmosphere in a gaseous state as pure water vapor. This clean, storable fuel powers vehicles without producing soot. Mastering the concepts of separation and energy transfer gives you a perspective on the state's most valuable future industries. If you understand how matter behaves, you are better prepared for the jobs emerging in your own backyard. Before the final farewell, look back at the logic you've mastered so far. You've seen that matter is constantly moving and that every transformation requires a balance of energy. You can trace almost every change on Earth back to the sun. That solar energy travels through plants and onto your plate, eventually powering your own muscles. You've learned to recognize reversible changes, like water freezing into a solid state and then melting back into a liquid without changing its identity. Regardless of its form, all of it is classified as matter. You also know how to spot irreversible transformations. When iron reacts with the environment to form rust, the material has undergone a permanent change. We have traced the path from the kitchen sink to the coastal salt flats, proving that these principles are visible everywhere you look. Chemistry provides a functional description of how your day actually works. Look at a construction site, a kitchen oven, or a new factory, and explain the physical logic behind them. The chemical view of the world is yours now.